Integrated Geometry 10.4. Welcome to the world of circles. In this lesson 10.4, we look at the inscribed angles and polygons. What is an inscribed angle? If I have a vertex or a point on the circle, let's call this is point P, okay? If I have a point P, now if I want to draw an inscribed angle, I will make two chords on the circle, or I can make two, where is it? There we go. Okay, I can make two chords, or I can make a ray out of that is fine too. Okay, two rays share the same point on the circle will make an inscribed angle. There we go. Okay, you see it? This angle P that is made up by the two chords, or it is made up by the two rays. This angle right here, angle P, is called the inscribed angles. By definition, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. There it is, okay? Then there's another name that you need to capture as well. This minor arc that is made up by the inscribed angle, this minor arc right here is called what? To this angle, to inscribed angle, it is called the intercepted arc to the inscribed angle P. That's just the vocabulary for us to learn. Now, we are going to measure an inscribed angle on the circle. What do we know? Now look at this. Can I give you a big hint? Okay. What if right now the center, okay, look, the center of the angle is right here. Suppose the center of the angle, okay, here you go. This is the center of the angle. Mr. Dang just forgot to put that right there. If this is the center of the angle, the center of the circle, then look at this. If this is the center of the angle right here, well, I forgot to give you the center, right? Center O. Okay, now, by nature, this is the definition. By nature, the inscribed angle has a measure of 1/2 of the intercepted arc. There we go. The inscribed angle has a measure of 1/2 of the intercepted arc. Let's call this is A, point A, this is point B. Okay, so you guys register that into your brain. The inscribed angle P is 1/2 of the measure of the degree of the minor arc AB. Okay, makes sense? So if the minor arc AB, let's say if it is 80 degrees, what is angle B? The inscribed angle P, 40. Vice versa. If you don't know the intercepted arc, but if you know this is 40, then what can you tell? The intercepted arc. That's right, twice of that inscribed angle. That's the theorem for you to capture, okay? It works well with the diameter, and then you can see as well. Look at this. What do I mean by trying to show you the center of the circle? Here we go. If Mr. Dang drawing, look right here. Suppose I am drawing the diameter right now. Look at this. If Mr. Dang draw a diameter, there we go. Look at this. This is a cool thing I want you to capture. The diameter, let's say this is B, this is C right here, okay? Diameter divides the circle into two halves, which is semicircles, okay? Any point on this right here is an inscribed angle to the two core. Let's call it, let's say from that to this right here. Can anyone tell me what is this angle right there? That's right, 90 degrees. Because the intercepted arc, CB right now is a semicircle. And CB is what? CB is, there we go, CB, the minor arc, the semicircle is 180. Therefore, let's call this right here is point X. So the angle CXB is an intercepted arc. Angle CXB is an it is an inscribed angle with the intercepted arc semicircle CB. Since CB is 180, therefore this guy is half of that, it's 90. What about another guy? What about this, another point right here, like I draw to you right here? Okay, will serve you well. There we go. How about this is Y, and this is another inscribed angle, XYB. Can anyone tell me what is this angle Y right here? Haha, it is also 90. Cool. How about this over here? There. Now we're talking. You see how beautiful this is? This is how space people will find each other, find themselves. This is, let's call this is V. The inscribed angle BVC is made up by the intercepted arc CA. And intercepted arc CA is 180. Therefore, this guy is also 90 degrees. Bingo. Register that in your brain and we are good to go, guys. We are good to go. What is the relationship between the inscribed angle and the intercepted arc? It is the inscribed angle is 1/2 of the, that's right, intercepted arc. Register that, you are good to go. Now, let me move into another easy concept that sets you up for your homework. Mr. Dang, what if I have, let's say, I have two inscribed angle with the same intercepted arc. Are they congruent? You betcha. Here we go. Here we go. What if I have? There we go. If this is A, this is B, and this is C. Just like this. Guys, look at this. There we go. The inscribed angle, if they have the same intercepted arc, your conclusion is they are congruent to one another. Okay? How about B? How about D right here? If they have the same intercepted arc, what is your conclusion, guys? Shout it out. There we go. Then this angle right here, there we go. Congruent to this angle right there, because they both have the same intercepted arc or congruent intercepted arc. That is your theorem 10.8. Apply that theorem, will take you a home run, okay? Set you up for your homework and make sure not just the inscribed angle will be the same if they both have the same what? That's right, intercepted arc, or the intercepted arcs are congruent. It will also make the inscribed angles congruent. Make sense? Okay, so there we go. That will give you a big thing, okay? BC. All right, now let's move into another easy concept right here, and that is, like I shared on 10.4, and that is the polygons. Okay, what do you mean by inscribed polygon and the circumscribed circle? Suppose I have a circle, okay? And then in circle right here, can I draw a triangle inside, or the vertex of the triangle land on the circle? And then the circle is being what is called inscribed by the circle. Okay, triangle is an example of polygon. There we go. Right here. Three sides are inside the circle, and the vertices of the triangle is on the circle. In this case, you call a triangle is an inscribed polygon. Meaning, or you say the circle circumscribes the triangle. Make sense, guys? There we go. All right, I just want you to understand that. And what does the theorem say in 10.9? Okay, theorem 10.9 says this. Can I go back to right here? Let me see. I picked someone really clear. Go back right here with me. Okay. Saying this. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of that. Here we go. If a right triangle is inscribed in a circle, okay? If a right triangle CXB is a right triangle. See it? With the vertex 90 degree X right here, or CYB is a right triangle with the vertex right here, or CVB is also a right triangle. If a right triangle is inscribed in a circle, you see all three sides inside and the vertices on the circle. If that is the case, then the hypotenuse is what? That's right, is the diameter. There we go. Piece of cake. You guys like this. You love circles, don't you? So now it comes very natural to you, and you see that right there. And you can use the converse theorem as well, which is if one side of an inscribed triangle is a diameter of a circle, then the triangle is what type? It is a right triangle. Got it? Okay, I repeat conversely. If one side of an inscribed triangle is a diameter of a circle, then the triangle is a right triangle, and the angle opposite to the diameter is the right angle. Perfect, perfect. Guys, apply that. 10.4 is a self-explanatory, and you guys are smart, genius people. Come on, man, go for it. Now let's go to the concept. Oops, I just kicked the video. How about go to 10.10 theorem, and now we're looking at the inscribed quadrilateral. Not just inscribed triangle, but now we look at the inscribed quadrilateral. What does that look like? Here we go. Okay, you hear the sound? Ooh. There we go. Suppose I have a quadrilateral right here. Okay, all right, let's bring the circle back. Okay, I am limited. Whoa, y'all, would you accept that? Beautiful. Okay. If I have a quadrilateral, okay, whose vertices on the circle like this. Okay. Talk to me, guys. Talk to me. In this right here, what do you call the name of the quadrilateral? The quadrilateral A, B, C, D. Quadrilateral ABCD is called the inscribed quadrilateral, meaning all sides are inside of the circle and all vertices on the circle. Okay? Or you can say the circle with the center, let's call it O. The circle O circumscribes quadrilateral. Or the quadrilateral is being inscribed by the circle. There we go. Okay, now, if this is the case, then guess what? Can you tell? What's the theorem? It says this. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. I repeat. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Meaning, show me the opposite angles to angle C. Look. Opposite angle to angle C is angle A. They are not congruent. They don't have to be congruent, okay? But the opposite angle is right there. Look at the intercepted. Look, this is look at the inscribed angle BCD. BCD. What is the intercepted arc of the inscribed angle BCD? Ah, this arc right here. You see it? There we go. Angle BCD has an intercepted arc BD. What about angle or the inscribed, the inscribed angle A. The inscribed angle A. What is the intercepted arc of the inscribed angle BAD? That's right, it's right here. Perfect. Oh, look. The green and the red, together they make a circle. So if together they make a circle, what is the degree of the whole circle? That's right, 360. And we know that the inscribed angle is half of the intercepted arc. Therefore, angle A, let's call this angle A, plus angle C equals what? Oh, can you see that, y'all? Let me see. Okay, let me see. Wow. Almost, that's right. Angle A plus angle C, look. Then angle A plus angle C, okay? Let me put down here so you can see. Therefore, angle A plus angle C is half of the 360, which is what? 180. There we go, perfect. Theorem 10.10 states perfectly. And that is, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. See it? And same opposite angles for B and D would work well as well. Look, if I do this, see right here, angle B and angle D. There we go. B and D together, they make a, look, perfect. circle. There we go. That's angle B. And here we go. This is angle. This is angle. Let me use dark ink too. This is angle D. Inscribed angle D is intercepted arc right here. You see it? So there we go. Together they make perfect 360. So the sum of them is half of 360, which is 180. Therefore, the opposite angles are supplementary. So state 10.10, use that, and then you have a big question to challenge you. In what case a quadrilateral can be inscribed by a circle, which you will tell me. Look with me in example 5. Okay, let's look at example 5, shall we? Example 5. Did you hear the dog barking outside? Okay, here we go. Example 5, you will have now a quadrilateral, and that is, okay, can I erase this? Okay, here we go. All right, okay, here we go. You have Q right here, and you have R right here. You have S right here, okay, and what else you have? You have P right here. I think that's P. There we go, P. Okay, all right, let me close all of this. Save the ink of this. All right, okay, you ready? Here we go. Here we go. All right. Okay, now I am going to go ahead and draw this quadrilateral, or shall I say properly, the inscribed. Okay, see if I don't close it, the ink's running out. The inscribed quadrilateral. There we go. Okay, you guys are good? Hope your day is going well. There we go. Okay, now we know this is 80 degree, and this is like say X degree. If this is a 75 degree, and that's Y degree. Guys, this is really insulting your intelligence, right? First of all, talk to yourself. Q, R, S, P, are they inscribed quadrilateral? Yes, indeed. Makes sense right there. Therefore, look at this angle 75. It is intercepted by the arc RS. Angle Y, intercepted by the major arc SQ. So you see together, these two opposite angles, they make perfect circle 360. Therefore, the sum of them together is what? Yep, the sum of them, add them together is 75 at Y equals 180. Solve that for Y, what you get? Ta-da, you got 105. Perfect. Same thing. Can you solve for X? 80 plus X is 180. Right, so that makes 100. Okay, guys, I'm insulting your intelligence. I apologize for that. Okay, so 10.4, almost done. And we are done, not just almost. That's the concept right there, guys. Okay, you got it? All right, let's move to next video with 10.4.